Hello everybody, my name is Roman Rodriguez and we are on chapter 8 of physics for grade 9 and 10. In this chapter we'll be discussing about work, power and energy. So this is the first lesson. So let's start with work. Now work is defined as a measure of energy transfer that occurs when an object is moved over a distance by an external force and this force is applied in the direction of the displacement. So in other words, we can say that work is a product of force into displacement. Mathematically, we can say that W is equals to F into D. F is force and D is your displacement. Now, if this force is being exerted at an angle along x-axis, so we can say that work done is equals to F into D times cos theta. W is equals to Ft cos theta. The unit of work is joule, and 1 joule is equals to 1 Newton meter. Joule, in other words, is defined as the work done by a force of 1 Newton in moving a body through a distance of 1 meter in the direction of force. Okay, let's move on to the next topic, that is power. Power is the rate at which work is done. Now, in other words, we can say that power is equals to work done upon time. It's a ratio between work and time. So, mathematically, we can say that work over time is equals to power, or P is equals to W upon T, where P is power, W is work, and T is your time. Now, the standard unit of power is watt, and as it is implied by the equation for power, a unit of power is equivalent to a unit of work divided by the unit of time. So, hence we can say that watt is equivalent to 1 joule per second. Now, for historical reasons, the unit of power was is horsepower. So, in the early British engineering system, the unit of power was horsepower or HP, and 1 HP is equivalent to 550 foot-pound per second. Or we can say that 1 horsepower is equals to 746, that's approximately 750 watts. Now, the expression of power, as you know, we just discussed it, is work upon time. And since this expression of work, is force into displacement, so when we replace work by force into displacement, so we can also write power is equals to force times displacement upon time. And displacement upon time, is equals to velocity. So we can also say that power is a product of force and velocity. As you can see over here, the equation, uh, it is represented mathematically. Power is equals to force times displacement upon time, and power is also product of force into velocity, because displacement upon time is velocity. Right. Now moving on to energy. Energy is the ability of a body to do work, or an ability to perform work. Energy can neither be created nor destroyed, but it can only be transferred from one kind to another. The unit of energy is the same as that of work, which is joules. So energy is found in many things, and there are different types of energy, but all forms of energy are either kinetic or potential. I'll be discussing about kinetic energy and potential energy in my next lesson more in detail. I'll also derive the equation for kinetic energy and potential energy, and also tell you the interconversion of kinetic and potential energy. There are various types of energy: mechanical wave energy, chemical energy, electrical, magnetic, radiant, nuclear, ionization, elastic, gravitational, thermal, and heat energy. So with this, we end this first lesson of chapter 8, work, power, and energy. I hope it is understood and clear to you all, and hope to see you in the next lesson. Till then, take care.